Imaging, how machines see. To see and navigate in the real world is a huge challenge. To do what our human eye and brain does requires not just one camera, but a multitude of different sensors and processes. To see requires a system. The first challenge for machines to see is to recognize people. Facial recognition is the process computers use to identify people's faces. Using photos and more recently 3D scans, the computer breaks down the face into its core elements that makes us all individual and identifiable. Our identifying features are saved and used for future identification. The features the system looks for are the width of the nose, the depth of the eye sockets, distance between the eyes, the shape of the cheekbones, and the length of the jawline. Thermal imaging measures heat by measuring the amount of infrared light. Infrared is invisible to our human eye, but with the use of a bolometer, can give us a decent read of the variation in temperature within a given image. There are two types: cryogenically cooled, which is expensive and bulky, but very accurate at 0.1 degrees and a really good range of 300 meters. The other is uncooled, which is cheaper, more usable in size and weight, but a less accurate option. The main advantage of thermal imaging is it sees what humans cannot, and it provides a unique type of sensor that covers a unique type of blind spot. Short-range 3D scanning from 0.1 meter to 1 meter is good for common objects we see around our houses. The first type is triangulation scanners. It uses a laser and an offset camera at a known distance. The known offset allows the processor to calculate the angle of the laser hitting the object to the camera and then able to calculate the distance. The laser can project in lines, or it can project patterns and in real time. Structured light scanners, similar to triangulation, except it uses a projector, projecting out visible light or infrared light in a known pattern. It can refresh quickly and scan the whole field of view at once and is real time. Photogrammetry can be done with any camera, but for a really accurate result, you need a dedicated room with multiple cameras, good lighting, and the cameras need to be positioned in incremental angles around the target object. For a longer range above 1 meter, the best option currently are LiDAR sensors. These fire a laser and record the time it takes to hit the target object and bounce back. Knowing the speed of light, the distance can then be recorded. The laser is firing at a point, so while they have a fast refresh time, they have to move around the environment to scan it. They move in a pattern similar to the way a cathode ray tube TV refreshes. They are getting smaller, but the mechanics of rotating the laser has made the machines quite bulky and with high maintenance requirements. There's a small one on the Xiaomi robot vacuum. The Xiaomi robot vacuum is an example of how visual systems combine. It can see and on a budget. It uses LiDAR, but only in one axis. The laser spins on a tank-like turret on the top, and with the help of onboard processors, gradually creates a 2D map of your home. All up, it uses a system of 12 sensors to help it do that task. Google Earth 360 View Camera is a more advanced version of the 360 Street View Panorama. The system 3D scans the environment to allow the software user to actually move in the environment, into a virtual version of the environment, rather than just rotate on the spot like it used to. It achieves this by using 11 lens very high resolution cameras, 2 puck-shaped LiDAR sensors for the 3D mapping, plus additional traditional cameras positioned all around the car. The Vive VR headset. The Vive uses its own unique version of structured light. The user is restricted to one room, but they can move around in that room. The Vive comes with 2 lighthouses that project light patterns into the room, similar to structured light, but not being projected from the device or at a fixed distance from the cameras on the device itself. There are small cameras all over the headset measuring where the light is hitting and using it to build the room and position the headset. The headset also has gyroscopes. So the next step above this one, so while the Vive kind of cheats, the Magic Leap one is actually doing it in completely. It can map the entire area you're in real time. The way it maps the room, it can do it without any outside assistance, like exterior cameras or lighthouses, and it allows you to walk freely from room to room and coming back into a room, the device will actually remember where you've left virtual objects, and they'll still be sitting there doing exactly the same thing, reacting to the furniture in the way you left it. The middle two sensors that you can see, structured light. This machine is still very new though, so a lot of the sensors we don't understand how they work. But the main thing is it's a mix of technologies to create a system. Thank you.